Hello viewers, in today's session we are going to discuss some important and conceptual problems related to derivatives, right? So here we'll solve a variety of problems in which we'll make use of some important concepts, right? So let us solve these problems one by one. So let us consider this problem where we are given a function y that is equal to sine inverse cosine x plus cosine inverse sine x, and we have to find out the derivative of y with respect to x, right? So here we'll write dy over dx, and we'll differentiate. First we'll differentiate this function, and we have d by dx of sine inverse cosine x plus then we'll differentiate this function with respect to x, right? So here we are going to make use of some concepts from inverse trigonometric functions, right? Now see, we know that sine inverse of sine theta is equal to theta when theta belongs to this interval, that is minus pi by 2 to pi by 2, and cosine inverse of cos theta is equal to theta when theta belongs to this interval, that is 0 to pi. So this interval is the principal value branch of sine inverse function, and this interval is the principal value branch of cos inverse function. So here we'll make use of these two results, right? So now we can write here sine inverse, and we can now express this cos x as sine pi by 2 minus x, because here this angle, that is pi by 2 minus x, it belongs to this interval, right? That is minus pi by 2 to pi by 2, and here we'll express this sine x as cos. Here we'll write pi by 2 minus x, right? Because sine pi by 2 minus x is equal to cosine x, and cos pi by 2 minus x is equal to sine x, right? And here pi by 2 minus x, it also belongs to this interval, that is 0 to pi, right? So now we can take this angle as theta, and also this angle as theta. So now we have d by d. So now we have d by dx of sine inverse of sine pi by 2 minus x, right? And due to this result, sine inverse sine theta is equal to theta. So here we have now simply theta, that is equal to pi by 2 minus x. And here we have d by dx of cos inverse cos pi by 2 minus x, and due to this result, cos inverse cos theta is equal to theta. So here also we have pi by 2 minus x, right? So now the derivative of pi by 2 is 0, and the derivative of x with respect to x is 1, and here we have the derivative of pi by 2 with respect to x is 0, being a constant, and here the derivative of x with respect to x is 1. So here we have minus 1, and here we have 0 minus 1 is minus 1, that is equal to minus 2, right? So the derivative of this function with respect to x is equal to minus 2. So now consider this problem where we are given y is equal to f of 1 over x, and f prime of x is equal to x cube, and we have to find out the value of dy over dx at x is equal to 1 over 3, right? So here what we will do, we'll first differentiate y with respect to x. So we write here dy over dx, and we have d by dx of f of 1 over x, right? So first we'll differentiate f of 1 over x. So here we have f prime of 1 over x, right? And then by chain rule we'll differentiate 1 over x with respect to x. So here we have f prime of 1 over x, and the derivative of 1 over x, that is x raised to minus 1, is given by minus 1 x raised to minus 1, that is minus 1 x raised to minus 2, that is minus 1 over x square. So here we have minus 1 over x square. So we can now write minus 1 over x square, and here we have f prime of 1 over x, right? So now we'll make use of this result, right? So here we are given that f prime of x is equal to x cube. So let us replace this x by 1 over x, because here we need to find out f prime of 1 over x. So now replacing x by 1 over x, we have f prime of 1 over x is equal to 1 over x, and here we have cube. So now f prime of 1 over x is equal to 1 over x cube, right? And substituting the value of f prime of 1 over x as 1 over x cube in this expression, we have now dy over dx is equal to minus 1 over x square, and here we have 1 over x cube. Now by the laws of exponents, here we have minus 1 over x raised to 2 plus 3, that is 5, right? So dy over dx is equal to negative of 1 over x raised to 5, and we have to find out the value of dy over dx at x is equal to 1 over 3. So let us now substitute x is equal to 1 over 3 in this expression. So we have a dy over dx is equal to minus 1 over 3, and here we have 5. So we have minus 1 over 3 raised to 5, and taking 3 raised to 5 to the numerator, we have minus 3 raised to 5, and 3 raised to 5 is equal to 243, right? So the value of dy over dx at x is equal to 1 over 3 is equal to minus 243. So now consider this problem where we are given a function f of x that is equal to x minus greatest integer of x minus cosine x, and we have to find the value of f prime of pi by 2, right? Now see, the approximate value of pi by 2 is given by 1.57, right? And here we have greatest integer of x, right? So here we see that when x is equal to pi by 2, then the greatest integer of x, that is equal to 1, because here 1.57 is greater than 1, but it is less than 2, right? So the greatest integer of pi by 2 is equal to 1, right? Because 1.57 is greater than 1, but it is less than 1, and due to the definition of greatest integer function, greatest integer of x is equal to the greatest integer equal to or less than x, right? So here we can now write this function in a modified form, that is f of x is equal to x minus 1, right? Because greatest integer of x is equal to 1, because in the neighborhood of pi by 2, the greatest integer of x is equal to 1, and here we have cosine x. So now we can differentiate f of x. So f prime of x is equal to the derivative of x minus 1 minus cosine x, and the derivative of x is 1, derivative of 1 is 0, and derivative of cosine x is minus sine x. And we have here 1, and here we have positive sine x. And now we need to find out f prime of pi by 2. So let us substitute x is equal to pi by 2 in this expression. So we have f prime of pi by 2 is equal to 1 plus sine pi by 2, and we have 1 plus 1 because sine 90 degrees is equal to 1. So we have 1 plus 1 is equal to 2. So the value of f prime of pi by 2 is equal to 2. So now consider this problem where we have to find the derivative of cos inverse 2x square minus 1 with respect to cos inverse x. So here this is a function, and here we have also another function, right? So we have to find out the derivative of a function with respect to another function, right? So for this what we will do, we'll consider here this function as, say, u. We can take u is equal to cos inverse 2x square minus 1, and here we can take this function as v, right? And we have to find out the derivative, that is du over dv, that is to find out the derivative of this function with respect to this function. So we have to find out the value of du over dv. Now here we'll first simplify this function by using a suitable substitution. So let us here substitute x is equal to say cos theta, right? So we'll substitute x is equal to cosine theta in this function. So we have u is equal to cos inverse, and here we have 2 cos square theta minus 1. And from trigonometry we know that the double angle formula for cosine function is given by 2 cos square theta minus 1, right? So we have cos inverse, and here we have cosine 2 theta. And again, by inverse trigonometric functions, we know that cos inverse of, say, cos alpha is equal to alpha when this alpha belongs to the interval that is 0 to pi. So here alpha is 2 theta. So due to this result, we can now write cos inverse cos 2 theta as simply 2 theta. So we have u is equal to 2 theta, and from here we can now express theta in terms of x, as theta is equal to cos inverse x. So now we have u is equal to 2 times cos inverse x, right? So now we have simplified this function like this: u is equal to 2 cos inverse x, and v is cos inverse x. So now let us find out du over dx. So the derivative, that is du over dx, is given by 2 times the derivative of cos inverse x. So we have 2, and the derivative of cos inverse x with respect to x is minus 1 over square root of 1 minus x square. So this is a standard result. So here we have minus 2 over square root of 1 minus x square. And now let us find out dv over dx. So the derivative of v with respect to x is d by dx of cos inverse x, that is minus 1 over square root of 1 minus x square, right? So now du over dv can be written as du over dx divided by, here we can write dv over dx, right? So now du over dx is minus 2 over square root of 1 minus x square, and dv over dx is minus 1 over square root of 1 minus x square. So now we can write here minus 2 over square root of 1 minus x square multiplied with square root of 1 minus x square over minus 1. So here these two terms get cancelled, negative and negative get cancelled, and we are left with a 2, right? So now du over dv is equal to 2, right? So the derivative of cos inverse 2x square minus 1 with respect to cos inverse x is equal to 2. So now consider this problem where we are given a function y is equal to logarithm of sine x to the base 2, right? And we have to find dy over dx. So here we'll make use of the base changing formula in logarithms. So we know that a log of say here we have b and here we have a, right? So we can now write here a log of b to the base e, and here we can now write log of a to the base e, where e is the exponential number, right? So this formula is known as a base changing formula. So here we have logarithm of b to the base a, right? And we have now converted the base to the natural log, that is the exponential number. So here we have changed the base from a to e, right? So we have log of b to the base e and log of a to the base e, right? So now if we compare this expression, that is log of sine x to the base 2 with this one, right? So we have the value of b as sine x, and the value of a is equal to 2. So we can now write y is equal to log of sine x to the base 2. So here we'll change the base 2 to the base e. So we can now write here log of b. b is sine x, and we have the base e, and then we have log of a is 2, and here the base is e. So now we have here modified this function like this, and here we can see that this term log of 2 to the base e is a constant, right? So now if we differentiate both sides, then we have dy over dx is equal to d by dx of log of sine x to the base e, and here we have log of 2 to the base e, right? And here log of 2 to the base e is a constant, so we can now write, or we can take a log of 2 to the base e outside this operator, that is the derivative operator, and we have d by dx of log of sine x to the base e. So we have 1 over log of 2 to the base e, and now the derivative of we know that the derivative of log x is equal to 1 over x. So here first we'll treat sine x as x. So we have 1 over sine x, and then by chain rule we have d by dx of sine x. So we have 1 over log 2 to the base e, 1 over sine x, and the derivative of sine x with respect to x is cosine x. And now we can write 1 over log of 2 to the base e, and this term is equal to cot x, because cot x is cosine x divided by sine x. So here we have cot x. So the derivative of y with respect to x, that is dy over dx, is given by cot x divided by logarithm of 2 to the base e.